Okay, we're talking about esterification. Very important about esterification is that it involves an alcohol, and there's something that you should know here to say only primary alcohol in this case are used to produce an ester. Now when you name an ester, for example, if we have got methanol reacting with the ethanoic acid, now the ester that will be produced when you name ester, we start with the alcohol. The alcohol will take the alkyl group, will end up with an "-ile", and then whereas the acid will take the anoate suffix there, anoate. Fine, therefore alcohol was started with meth, therefore we'll have the ester as methyl, and the acid is starting with eth, therefore it will be now ethanoate. As the case, then plus water. Fine. In most cases they can give you marks to say use structural formulae to draw this. Don't worry, when you draw the ester, remember the functional group of esters, they should be the cocoa. Those who know this one, they call it cocoa, which is this. Therefore this is the functional group, therefore you'll always have this cocoa, whereby this side of carbonyl is come from the acid side, and then whereas this is come from the alcohol side. So always bear in mind of those, very important. But what you should know again will be this one. If I'm given butyl propanoate, let's say butyl propanoate, they say name the alcohol. In this case, remember we said all esters are coming from primary alcohol, therefore it means that the alcohol that produces this ester will be butane 1-ol. That's the case, and the acid will be propanoic acid. Propanoic acid, that's the case. If you want to write the molecular formula of this ester, then it will be your 4 plus 3 is 7, it will be C7, then H14O2. So remember it has got CnH2nO2. That is the general formula for esters, CnH2nO2. That's the case. That's about esters and their conditions. Very important, you must know those ones. Now let's come to the crux of this section of reactions, which is now where we start with the first reaction. Very important, should be substitution. Substitution. Why substitution or replacement reaction? They call it replacement reaction. Fine. Why substitution is because we are starting from alkanes. Therefore alkanes have got single bonds. When we land compounds, organic compounds, then we start with this one. So from single bonds to single bonds, that's where substitution takes place. I mean that if I've got a single bond, that produces another single bond. So what are those single bonds? We'll be having three most important reactions. So substitution reaction, there are only three examinable reactions. Fine, with one, which is very important. Okay, fine. Substitution can be alkane, can undergo substitution reaction because they are not reactive. They can form haloalkane. We'll talk about the examples again. Alcohols can form also haloalkane, where now the OH is replaced by the halogen. The last one, which is very important, then is the haloalkane can produce an alcohol. So in this case now, when this happens, remember you will need the haloalkane to react with concentrated, this one dilute strong base. Dilute strong base can be sodium hydroxide, potassium hydroxide, or lithium hydroxide. So, or just say strong base, it's fine. Strong base. And plus also you need gentle heating, moderate heat, moderate, gentle. Some people they say gentle heat, some they just say heat. If you just write heat is fine, it's acceptable in this case. Now one example of this one will be if I've got, let's say, the very important one. Remember, in these sections you have to know the reactions that involve C3. C3 is the basis of many of those reactions. Now propane, which is this, when propane react with bromine, then it will form, normally it forms two compounds, 1, 2, 3. That's the first one, which is this. Plus HBr, and then the second one will be this one. I hope you know the homologous, this one, the IUPAC naming of these two compounds, and HBr. The first one is a minor product. Minor, it will be unstable, and the next one is the major product, that is the stable one. So the minor one will be the one that is having the, which we call it 1-bromopropane, and then the major one will be the 2-bromopropane. This is the one that you need to know, bromopropane. Fine. So that is when coming to substitution reaction that involves propane. And then alcohols, very easy to say. If I've got propane 1-ol, then undergoes the substitution reaction. Let's say you react this one with the NaBr, then it will form. Now again Br will be here, so we'll have 1-bromopropane, and then plus sodium hydroxide. That's the case. We'll make one simple conclusion. The last one, which is very important, we said, is where now we have got a haloalkane, which is your, let's say, 2-bromopropane. It has to, it has to react with strong base. Let's take this easiest one, sodium hydroxide, but should be in diluted form, remember, and then plus heat, then will form an alcohol. The alcohol, the OH, will be replacing the Br. This will be the case. And then plus sodium bromide. And this is the conclusion that I want us to make out of these three reactions anyway. There are only three examinable ones. In substitution, we said we are moving from single bonds to single bond. But one thing that you should take note is that in substitution, we have got, if I've got two reactants, I will also produce two products. That's one thing that you should know. You learned with elimination and addition that this is not the case. So two reactants, two products in terms of substitution. I think we are clear with substitution. We'll be moving to the next ones, but very important, please don't forget, substitution reaction requires diluted strong base. It can be potassium hydroxide, can be lithium hydroxide, or just in this case if you are giving in a reaction. So fine, you will have potassium bromide or lithium bromide. Thanks a lot. Let's see on this one, the elimination reaction.